So I'm here with Dr. Dan Work, and I just appreciate you guys' time. I want to talk a little bit about the I-24 motion test bed. So traffic, one of the engineering disciplines that has to do with human behavior. One of the worst things you're trying to figure out, right? Hydraulics, flow theory, all very predictable. You throw a human into the mix, whole different story. So this project is a lot about trying to analyze, trying to come up with solutions around what the human driver is doing. The I-24 Motion Project has a vision to create this premier test bed, open road test bed, and to integrate, to be able to analyze what traffic's doing, to also be able to test and analyze strategies such as integrated corridor management. We're out there actually right now, a building you guys may have seen on the corridor, 100-foot poles with arrays of 6 cameras each. It's going to have ultra high resolution cameras out there in order to see on a vehicle by vehicle basis the traffic interactions, be able to see into traffic. One of the really cool things about this project is the collaboration and innovation that we're bringing to the table. We've got partners all the way from Vanderbilt and private industry of all kinds in order to bring this project to the table there. One of the main things is being able to see into traffic. It's sort of kind of a funny thing to think about this test bed, this instrument we're building to be able to not just monitor traffic, but able to actually see into traffic or on a vehicle by vehicle trajectory basis. One of the better things about this project is to be able to look at how these strategies will pull together and be able to analyze this traffic. So I want to pull up one more thing here, kind of a background of the project. You see these three of the things this project will bring to the table is a huge advancement for traffic simulation industry. You go all the way from Bruce Greenfield back in the 1913, looking at traffic from just a camera on the side of the road. It's kind of funny, actually. Dan's from this area in Ohio where this actually happened. So you go all the way from that rudimentary style, looking at and analyzing traffic, all the way to the Lincoln Tunnel, back and forth traffic, trying to detect and analyze congestion, all the way to helicopters over the road trying to count traffic and be able to analyze congestion, to probe data, all the way through to now we'll be able to use 4K high-definition cameras to be able to, like I mentioned before, see into traffic and see on a vehicle-by-vehicle, lane-by-lane basis what the vehicles are doing, how they're interacting with both with each other and with the infrastructure. Oops. So here's just an example about the kind of the trouble sometimes that
worth 30 between the two of us? Okay.
Automated vehicles, autonomous vehicles might have with interacting with traditional traffic.
Okay.
No, does the video not work?
I wasn't sure, so I didn't know if you wanted me to cover any of your slides or if you wanted to just cover them or, yeah, the Nevi stuff.
Well, this video will show, if it was to play, it would show the white vehicle there on my right, your left, trying to merge into traffic on this roadway, and basically having to stop because it doesn't really know what's going on. It can see what's in front of it, but it really can't know how to interact with the traffic that's coming up around there. So one of the ways.
I think that'll be good.
Okay. Maybe the video's going to play. Oh, there you go. Oh, there's the video. Sorry about that. So anyway, you can see as this vehicle is coming up on the right here, and it's trying to merge. It's not able to get enough information in order to know exactly what to do at that merge point. So it actually has to stop right there. So we want to understand those vehicle interactions in order to be able to solve that problem. And we've heard before from Cisco and others that the technology is coming up so quickly. And you see the Waymo vehicle there that's stopped on the side there and it can't move forward. So this is the kind of thing we're trying to analyze and trying to implement solutions for. So one of the projects that this test bed will be able to really analyze in a very, very robust way is the I-24 Smart Corridor. And just this slide just showing the purpose and need for this project. As was mentioned before by the Commissioner and by President Boyd about safety. and this morning with the young man being hit by the vehicle on the side of the road, reducing the secondary crashes, improving travel time reliability is really what this project, the I-24 Smart Corridor, is about. And the I-24 Motion Project will be able to analyze how those strategies are interacting with each other, how the vehicles are interacting with each other, to see if the strategies that we're using are effective. So the I-24 Smart Corridor project, just a really quick thumbnail about that one. We're going to talk more about the Motion project, but this project is going to be able to bring to the table at least 3 or 4 brand new strategies to the state of Tennessee. Not only will it have variable speed limits, a lane control system you see on the top right of the slide there to give lane by lane indications of which lanes are open, which lanes are closed, and the speed limit in order to prevent that back of the queue crash, which is so common out there. If you've ever driven I-24 over in that area of town, the congestion and the stop and go traffic is obviously very frustrating. This project will help to reduce all that. We're going to be implementing not only variable speed limits, lane control system, but also in phase 3, a ramp metering system, which all those things, in order to optimize those and to make those that much more effective, this I-24 Motion 4K camera project will be able to really give us a lot of insight there. So here you see just a snapshot of what traffic looks like out there on I-24 today. What's called the famine traffic jam. Somebody taps their brakes ahead of you, everybody slows down in order to catch up with traffic, and then it starts to flow again. So these are the kind of things that Dan and his team will be studying to see how something as simple as adaptive cruise control can affect the traffic in that area there. And this is the kind of traffic we're also trying to improve upon for travel time reliability and safety on the I-24 Smart Corridor project. So now to hear a little bit more about the Motion project itself and the nuts and bolts of that, I'm going to turn it over to my colleague, Dan Work.
Thank you, Lee, and thanks to TDOT for really helping us on a multi-year journey, close the gap between research and innovation and deployment. I think that's been something that's been very challenging but important to do in the field of transportation science because it's an empirical field, right? You actually have to go out and get data about what's happening on the freeways if you want to try to improve it. And if you think about the larger landscape of what's happening in mobility, it's probably one of the most disruptive times in mobility since the construction of the interstate highway system. You've got all kinds of new technologies in the electric vehicles, in automated vehicles, in connectivity, in vehicles that are being shared. And these things are impacting the mobility patterns on all of the roadways. And we've got to have new technologies to be able to see what's happening there if we're going to have any hope at trying to improve these technologies. So I-24 Motion is really a chart towards getting better information. If we're using the same types of sensing technologies that we've used for the last 70 years to understand what traffic patterns look like on the freeways, and then we change all these vehicle technologies, it's going to make it really hard to understand whether or not those technologies are being optimized to get the most kind of benefit we can see on the freeway. So a lot of what we're trying to do with I-24 Motion is get the data that we need to drive a lot of the innovation for these technologies. So whether that is helping automotive manufacturers who are developing level 1, level 2 automated vehicle technologies, design those in a way that they're not just safe and comfortable and fuel efficient, but when you put them in the wild with the rest of us that aren't running automated vehicles, that they're compatible and that they are smooth. In fact, there's a huge open space to fight those types of phantom traffic jams that you just saw in the video that Lee showed, using only a handful of these automated vehicles. Just in the same way that 20 years ago, it's getting close to that, as the GPS devices started popping up on phones, it became possible to monitor traffic in a new way. And you didn't need every car to tell you what the travel time was. You just needed a handful. We think the same thing is true with automated vehicles. That once those start coming online at level 1, level 2, the type you can buy on the dealership today, designed intelligently, we're going to be able to make traffic better. That's just one example. Other examples, as you start thinking about all the different V2X and V2V technologies that are going out in the infrastructure, if we have ways where we can see in excruciating detail how those systems are working, we can take those technologies, optimize them, and then scale them across the infrastructure. There's a lot of opportunity to just push the foundations of our knowledge to advance what we can do in this space. And to give you an idea of sort of like where I-24 Motion is not just kind of recycling and repeating old ideas, it's really taking a jump change in terms of what we're capable of doing. The traffic simulation community has had as a backbone a really innovative project in 2006 that Federal Highways led in California called NG-SIM. NG-SIM stood for the Next Generation Simulation. What they did is stuck a couple cameras on a 30-story building on I-80 in downtown Emeryville, California, and they used that at the time literally to manually annotate the positions of all the vehicles that were traveling down the roadway. So the traffic simulation community, pick your favorite traffic sim product, a lot of the technologies that are baked in there are based on science and engineering that came from models that were generated in this 15-minute long, 1,800 vehicle data set. Okay, fast forward a bunch, and what have people done in the interim? We fly, literally, the federal highways are flying helicopters over freeways in different parts of the country right now to get snippets of how automated vehicles are interacting with the flow. Helicopters are expensive to rent, and it doesn't really help you get that longitudinal information about day to day what's happening on the freeway. People have tried drone technologies, but I-24 Motion is just night and day, going from like tens of thousands of vehicle miles of data to 200 million vehicles miles of data that is going to be collected and generated from I-24 Motion annually. So that really opens up new possibilities of developing AI technologies that are super data hungry, that need that data to unlock the performance that more classical techniques are not capable of doing. So I-24 Motions is really filling a gap in a whole bunch of really important ways. It's been a multi-year journey. We're really grateful. I know a lot of folks in the room have helped us in small and large ways throughout the history of this project. But one of the key steps was in 2020 getting a SEER approved to make building out a test bed eligible for federal funding. We built a validation system that's operational now for 2 years that basically allowed us to prototype the technology. There's not actually, we're pushing the limits of some of the cameras and some of the devices that actually handle all the bandwidth that those cameras generate so that we can generate the data on them. No one had done this stuff before, so we really had to prototype these systems out and figure out how they work. Other important steps is actually getting federal funding to build out the test bed. We've held industry forums. We've been out talking to all the other test beds spanning from Florida to Michigan to try to figure out how they operate those test beds, and we can pick some of the best practices as we unfold I-24 Motion.
Yeah, well, Diana.
Just to give you an example of what that validation system construction looked like, I mean, this was basically a pretty monumental effort that Stance Electric did at the time, basically raising these 110-foot tall poles. I mean, they obviously they sped up, but I think the last pole was raised in like 15 minutes. So really a pretty phenomenal infrastructure investment here to be able to get that near helicopter view of the traffic so that we can start improving these systems. Well, after the validation system was constructed, like I said, we basically have been prototyping and iterating on the technologies that sit at the top of the pole. These are all PTZ cameras that basically allow us to remotely calibrate the cameras and generate the imagery that we need for that high quality trajectory data that ultimately is what we see as scientifically useful. And this is another video that just kind of gives you an insight of what that looks like. We take these overlapping fields of view and synthesize all the images to get out the positions of the vehicles and how they interact with each other as they move down the freeway. So it's also helped us advance the computer vision algorithms to do that type of automatic, anonymous data generation. And at the end of the day, you get something that looks like that bottom video. That is actually real traffic on I-24 coming out of our validation system, and you can see the different trucks and different vehicles and how they interact. So doing that at a massive scale is really what this project is ultimately about. The technologies that actually do that behind the scenes, pretty much most of the techniques that are camera-based that try to get traffic information, or doing some notion of a technique where basically you try to detect all the objects that you see in a picture, in an image, in a video, and then from one frame to the next, you try to associate all the times you saw a blue car in the first frame, where's that blue car in the next frame? That's how you kind of associate these trajectories in the paths of the vehicles that go through here. And these techniques, I mean, there's a million different variations of how people build these algorithms, but what we've been thinking about doing is like how to make these algorithms even more computationally efficient and more accurate, recognizing that we're in a relatively clean environment looking at data on freeways. So probably some folks are familiar with scenes like this where you ask an object detector, your kids, where is Waldo, right? And an object detector, basically what it does is it goes and finds Waldo. And there's a tiny little square box. It's hard to see in the lighting here, but there's a tiny little box that found Waldo, right? That's what the image detection step is. It goes and finds where the cars are located. And then another scene comes along. You give the image detector another picture, and you ask again the same question, where's Waldo? And fine, you find it. Of course, on a freeway, this is very inefficient because when the image barely moves, Waldo also barely moves, so maybe you should just look where Waldo was last time and see if you can find him again. So we basically do that at a massive scale, and that allows us to significantly enhance on the freeway context the computational efficiency of what we're doing and also the quality of the ultimate data sets that come out of the system. So it's been really helpful to pioneer new algorithms that can power this system and really unlock the data that will help us advance the system. As the system has continued to evolve and as we've acquired the funding and Gresham Smith handled the design of the system, we've basically gone out and got a 40-pole system that's coming online as we speak. There are 31 poles that are currently standing on the freeway, with the remainder coming in just a few days. This is what a drive down I-24 looks like just 10 days ago, right? And you can see on the right these very tall pieces of infrastructure that give us that field of view. We just ran under one of the lane control system gantries, and you can start to see now where these things get like force multipliers, right? If the lane control system is not optimized, we can actually look from the trajectory data to find out why. Is it because the algorithm hasn't been fine-tuned, or is it because the driver behavior going underneath the gantry is distinct from what the model said it would look like? So it's just really helping us see deeper into the insights of what these systems are doing so that we can tweak the performance out of it that will ultimately make it work better. The testbed is nearing completion. As soon as we open the testbed, it's going to be open for a variety of different testing purposes. So I definitely encourage you to go talk to TDOT afterwards to figure out the possible ways that you might be interested in running tests, and we can walk you kind of through what it would look like to run one of those tests. The Circles project is going to be one of the first users of the testbed. It's a U.S. Department of Energy project. It's led by Alex Bayan at UC Berkeley. The high-level idea, the Circles, I know we were talking about running cars in circular tracks before, that driving on the speedway has some limitations. That's kind of a tongue-in-cheek name for this project, Circles. We're going to drive the Circles on I-24 instead, right? We'll get off at this exit, drive on the freeway for a bit, turn around, go do the same thing. But the high-level idea is we're doing it on an open road where we interact with real drivers on real freeways. And what we're doing in a fantastic partnership with automotive manufacturers, including Nissan, who has really stepped up to the plate and loaned us 100 vehicles that we can use to modify the adaptive cruise control that's on that vehicle in a small but important way, to actually design those controllers so that they will not just make the commute of the drivers using those vehicles smooth, but they also help smooth the traffic flow on the freeway. We're basically going to be driving those fleet of vehicles to explore what the future will look like if you had 3 to 5% of the cars that were running those types of technologies that were coordinating to try to make traffic better. How good can they do? This project is a way to basically explore what that future looks like by pushing all those vehicles into rush hour traffic in the morning, designed with new technologies to help fight those phantom traffic jams. And it wouldn't make sense to test anywhere else in the world except on I-24 Motion, because we need to see how those vehicles interact with the rest of the drivers on the roadway so that we can actually confirm that the technologies that we're putting out there are leading to the benefits that we're seeing on the freeway. So being able to measure that stuff is just so fundamentally important to make these systems more operational. Just to give you a glimpse of sort of what it will look like, we've been doing a lot of prototype testing in the previous summer. This is our fleet of RAV4s that we used in 2021. Basically lined up these vehicles, modified the stock adaptive cruise control systems in just a small way, got a collection of drivers from Vanderbilt and our university partners, lined them up on the side of I-24, got them all launched onto the freeway, and ran machine-learned adaptive cruise control systems on the freeway in these modified RAV4s. And this was a small-scale experiment. There were 11 vehicles in that test. It's a tenth of the scale of what we'll be running in November of this year, but really gives kind of a glimpse into like how these experiments are run and why they're going to be so important to unlocking that future technology on the vehicles. So where we're headed, basically, the nutshell of I-24 Motion is we're trying to measure what we are doing so that we can improve those systems. In a nutshell, that's it, right? And that's going to be really important. We're opening that test bed up with this Circles test that will launch these automated vehicle technologies that are designed to make traffic flow more efficiently on the freeway. And when the I-24 smart corridor comes online with the variable speed limits and the ramp control systems and the lane control systems that alert you when there are crashes ahead and try to mitigate the congestion that's generated from when adverse incidents occur, we obviously try to minimize those in the first place, but if we can detect what's going on and we can see how the system's responding, we can make those decisions faster, we can make those decisions better, and ultimately make traffic flow better on I-24 for commuters that are on there every day. Okay. So with that, I'll wrap up and just acknowledge that all the work at Vanderbilt is actually done by an army of fantastic students, and some of you may already have them in your internship programs. If not, you should. They're absolutely amazing, and they deserve all the credit that you see for the parts of the work that Vanderbilt leads. They're the ones that are ultimately responsible for that. So really thankful for your time, and we'll look forward to questions here shortly. So thank you.